This afternoon we're going to be talking about using your voltmeter. Now what we've got here is your basic voltmeter that many of you have used many times before. This is called a multimeter. That's because it does a multitude of things. It can measure voltage, resistance, diodes, and current flow. Also, this particular meter has the ability to measure frequency. Couple of things to know and watch out for on these machines when you're just hooking them up. If you're going to be using them to measure voltage, make sure that you have the meter leads in the proper holes. The black lead will go in the common. The red lead will go into the hole for volts, ohms, and diode testing. This particular meter is good for about 1,000 volts. Others do not have as high a voltage reading as this one does. They may be 750, they may be as low as 600 volts. Don't go above that for your own safety. Couple other things. When you're using the meter and you're using these leads are not all that tough. If you're measuring something and you push down too hard on whatever you're measuring, the probe tips right here can easily be bent. You can straighten them out. About the second time they get bent, though, when you go to straighten them out, they'll break, and that means you need a new set of meter leads, and that can be anywhere from $25 to as much as $75, so we don't want to break those. Continuing on, our first stop here is going to be using the meter to measure AC volts. Now AC volts are indicated by the squiggly line above the volt indication. AC is what's coming out of the wall, or alternating current. As we move up a little ways farther, we have DC volts, again indicated by the straight line above the volt indicator. DC is battery power. This meter has the ability to go to as little as 1 millivolt to as many as 1,000 volts. And again, watch that high level there. Don't go above whatever it's rated at for your own safety, because bad things can happen to nice people. This horseshoe-shaped affair indicates that you're measuring resistance, and that's the ohm. Now the important thing to notice when you're doing an ohm test is, as you take a look at the meter itself, you have a multiplier right over here. The M stands for million. So whatever this meter would read, you would take the reading times 1 million. Such as you take a look at that one, it's 9.86 with a multiplier of 1 million. So it's actually 9,860,000 ohms is what we're measuring. Now we can also have a K there. As you can see on this one, it's 10.01 K ohms. K stands for kilo, or 1,000. So that would be a multiplier of 1,000. So that's 10,010 ohms. And we can also move it over to where there is no multiplier at all. In that this particular one, we're looking at 1.1 ohms. Very, very low resistance. Again, this particular unit has the ability to go up to about 40 million ohms, and that's its top range. Other things to note on this one is keep your fingers behind the little barriers here. That does two things. If you're measuring resistance in this case, we want you to measure only the resistance of the component, not of your body. As we can see in this one right here, it's about 9.86 million ohms. If we go across it with our fingers and let our fingers actually touch the probe tips, you can see that the total measurement drops down to 4.1 million ohms. That's because your body is in parallel with the measurement. You're getting an inaccurate measurement, and that can cause you to replace parts that you don't need to replace. Again, when we let it go, it goes back up to about 9.86 million ohms. Now, other important reasons for wanting to not let your little pinkies touch the probe tips, imagine if you're measuring voltage. You just put your body in parallel with whatever you're measuring again. So if you're measuring AC voltage, 120 volts, 240 volts, or heaven help you, the maximum this thing can put out or can take, which is 1,000 volts, that's going to go through your body, and that can kill you, and that's a bad thing. Other things that we can measure on this particular meter is diodes. Now this diode requires a special section on this electronic meter. If we measured it with an ohm meter, it would indicate that every diode that you ever look at would be defective. You cannot use the ohm meter portion of this meter to measure a diode. It just won't work. It won't give you an accurate reading. But if we put it over here on the diode section, as we are right now, and notice that we have not moved any of our test leads yet, we're going to make two tests on this one. As we make the initial test here, notice that the meter says OL for over limit. If this diode is good and we reverse these two leads, it should read 0.4 something. And in this particular case, it measures 0.445 volts. This indicates that the diode that we're measuring is a good diode and indeed can be put back into service. The last two areas that we're going to be checking are going to be amperes, milliamps, and microamps. So as we change the rotary switch to the amps or milliamps, we're also going to be changing the position of our red lead. The red lead will come out of this area and it will go over here. If you're measuring amperes, it goes into this one. If you're measuring milliamps, it would go into this hole over here. Now when you change from here to here, this meter becomes a very, very low resistance meter. You have to know approximately what current flow you're going to be measuring with these probes. This meter can only do 10 amps for an extended period of time, or it can do 20 amps for no more than 30 seconds. Otherwise, you stand a chance of blowing a fuse that's inside the meter. And that fuse is really expensive. It's about $5 each, so you don't want to blow those up too often. Now, once you've made your measurement and you know what the current flow is of whatever device, then you're going to want to remove the meter lead from the amp area, put it back over here, and then turn your meter to the off. Get in the habit of doing this. That way you don't forget it. Leave it in the amp section, and then if you go to measure battery voltage or something like that, you just frag that fuse immediately, and you got to put another fuse in it. And that's about all there is to using this, except for one last area that we can do, and it's very important for power plant operators, and that's checking frequency. If you take your meter and you turn it again to AC volts, and you hit the little black button right over here that says HZ, which is short for Hertz or frequency. Now what you can do is simply slide the meter into any outlet in the village, and you can tell exactly what the frequency is of your generators, no matter where you are in the village. And what we should be looking at is 60 Hertz. And that, ladies and gentlemen, is using your meter.